Hello students. So today we are moving on to our next experiment, that is to design combinational logic system for a specified truth table. So before we start for designing these on TinkerCad, we should first create a problem. From a truth table, we should design a Boolean expression, and from there we are going to design the combinational logic circuit, and then we are going to move on to TinkerCad to verify the truth table. So let's start with a basics of our combinational logic system. So now let's first discuss about the combinational circuits. Basically, combinational circuits are memory-less digital logic circuits, the output of which are dependent at all times on the combination of what? Of inputs that we provide to them. Right? So when we talk about combinational circuits, the very first thing is that they have got no feedback. When we talk about feedback systems, we talk about sequential circuits. This is the main difference between combinational and sequential. Combinational are memoryless, while sequential circuits are having memory in them. They depend upon the output depends upon the previous input. So basically, when we talk about your combinational circuits, the main thing that we talk is they depend. These combinational circuits can be specified by the very first thing is Boolean algebra. You all know what is Boolean algebra? That is the algebraic expression showing operation of logic circuit. Like if I say that I have got the output as A bar plus B bar, then I will be talking about the algebraic expression. The second one is the truth table, in which a tabular form of output with respect to the logic of input is defined. And last one is the logic diagram. That is the graphical representation. And this we represent using your different OR gate, NOR gate, NAND gate. With all these, we can represent what your this expression or what your this truth table explains with this circuit, with wiring and all. We come to know that how the gates are adjoined to provide us with a given output. So now we come on to our first problem of how we are going to design our combinational circuit when the truth table is provided to us. So now we will be discussing two circuits. Our question 1 is having to design a combinational circuit with two inputs which produce output as logic 0 when any one input is 1. So let's say that we have got two inputs A and B and the output is Y. So how you write it? It is always 0, 0, 0, 1, 1, 0 and 1, 1. So what our statement says that firstly we have to write the truth table from your this statement that logic is 0 when any one input is 1. So here you can see the in one input is 1, one input is 1. So that means the output should be 0 here when any one input is. So here two inputs are 1. So again the output should be 0. So only in our this case the output will be high. So for this we have to write the K map now. So this is my A and this is my B. This is my 0 and this is my 1 here. Similarly 0 and 1, where your 0 stands for A bar and 1 stands for A. Similarly 0 for B bar and 1 for B. So I am going to write for 0 0. So here you can see for 0 0 the output is 1. For 0 and 1 output is 0. Again for 1 and 0 0, and for 1 and 1 again 0. So we have got only this one, and to indicate our this one we have got this thing. So that means your this one indicates that when output is A bar B bar, the output will be equal to 1. So your this condition, this equation defines the output. So if you want to design this circuit using your NOT gate and AND gate, so you have got your two inverters, because input you are providing as A, here you are providing it as B. So at the output you are going to get A bar, B bar, and these both are going to act as the input to the AND gate. So the output is A bar, B bar, and with this you are going to get your this truth table. So this is the circuit, how you design a circuit from the truth table. So now this whole thing we are going to design with our TinkerCAD, and then we are going to verify our this truth table from our this circuit. So you should only remember that the output should be 1 only in case when both the inputs are low. So let's verify, and now let's go to your TinkerCAD. So now we have come on to our TinkerCAD. Here we have got this 7404 is the NOT gate IC and 7408 is the AND gate IC. So the pin configuration is same. This VCC, this pin 14 is VCC, and this 7th pin is ground. Same here, this 14th pin is VCC and this 7th pin is ground. Now NOT gate is having only one input, one output, one input, one output, one input and one output. Similarly on this side also. While here AND gate, this we have already discussed. This and this are the input of the first AND gate, and this is the output of our this gate. So because we are only going to use a single AND gate, so we will be concentrating only on the pins 13, 12 and 11. So now let's make the connections. So the very first thing we are going to do is we are going to connect the positive and the negative to our this pin. Whole is going to get the positive supply because this is our VCC pin. So here you can see when I have given this the VCC as 5 volts, our this 14th pin of both ICs are going to get the 5 volts, and this is our ground pin. So all the pins are going to get grounded. So next I am going to give my this first pin, this first input to my this NOT gate. Then I am going to give my second input to my second NOT gate. Here you can see this is my input and this is my output. So just a second. So this should be going to next one, right? So now I will be giving my this in output of our this NOT gate to my first pin of the AND gate, and then the output of this NOT gate as the second input to the AND gate, and the output from this AND gate should go to the LED, and my this LED should also get grounded. So now we have to cross verify what we designed in our combinational circuit on the whiteboard. So let's start with the simulation. Let's first check the circuit again. This is my pin number 1. This is my pin number 1 that has logic input 1 that has gone to first NOT gate. This one has gone to second NOT gate. Output of my this logic gate has gone to input as for the AND gate, and this has gone as the second input and this output layer. So now we are going to start the simulation. So here you can see that whenever my any input is high, the output will be low only. For 1 1 output is low. For 1 0 again it is low. For 0 0 it is high. And for 0 1 again it is low. So only when both the outputs are low, both the inputs are low, the output is high. So this verifies our circuit. Here what we have used is, this is my NOT gate and this is my AND gate, as we designed for the combinational circuit for our design problem 1. So now we are going to move on to our next design problem with 3 inputs. So now let's move over to our whiteboard again. So now we come on to our problem 2, in which you are given that you have to design a 3-input digital circuit that will give a logic 1 as the output when the binary number formed at the input has more ones than zeros. What does this mean? That if it has got like 0 1 1 1, number of ones are more than zeros, only then the output will be 1. If the inputs are like 0 0 0 1, then the output should be in the low state only. So let's first form the truth table with 3 inputs, A, B, C, and this is my output Y. So let's first write down our inputs. So this will be 0 1 0 1 0 1 0 1. This will be 0 0 1 1 0 0 1 1. And the last one will be, so here we go with the output. So here we can see that there are 3 zeros, so output will be 0. Now number of zeros again are more than the ones, so again output is 0 0, and here the number of ones are more than 0, so output is 1, again 0, again 1, again 1, and again 1. So this is my output. So let's make the truth table from our this circuit. So let's make the K map from here. So this is my A, while this is my BC. So this will be having 2 states only, 0 and 1, while this will be having 0 0, then 0 1, then 1 1, and the last one will be 1 0. So let's put the values. So for 3 zeros it will be 0, then 0 0 1 will give me again 0, then 0 1 0 will be 0, this will be 1, so this will be 0 again, this will be 1 1 and 1. So let's make the pairs here. So one pair is this, that is going to provide me with the value BC. Then one pair is this, that is going to provide me with A and C. Then one pair of ones is this, that is going to provide me with A and B here. So that means this is going to be my output for which the circuit is to be designed. So if you just check it out here, then you have got 3 AND gates, and the output of these 3 AND gates are to be fed to our this OR gate, because these are to be OR. So this are to be fed to the OR gate to provide me with my this Y. Here the input will be AB, AC, BC. So now the main problem that is going to come to us in TinkerCad is that we are not having a 3-input OR gate, but we are having a 3-input NOR gate. We are not having a 3-input OR gate. This one we are not having in TinkerCad. So what we are going to do is, so the main thing that I'm going to do is I'm going to take Y bar as the output, because that will be the NOR gate with which I'm going to design. So the output that I'm going to get in TinkerCad will be just opposite to what we have designed here. So we have to only verify our this truth table that I have just written with green pen here, right? So now what we are going to see is that for 0 0 we are going to get 1, for 0 0 1 again 1, for 0 0 1 again 1, for again for 1 0 0 again I am going to get 1. So you can see that for more number of zeros I am going to get 1. So let's just verify our this truth table there. So now let's move on to TinkerCAD. So here you can see that I have got my this as the AND gates, while this is my NOR gate, right? So this is my 3 pins. So here you can see that if I just write here, so you can see here I am getting quads. These are 2 inputs all, but here you can see triple 3 input NAND gate, triple 3 input AND gate, triple 3 input NOR gate. Similarly here, dual 4 input NAND gate and dual 4 input AND gate. So here you can see that I don't have a OR gate. So I am going on with my this 3 input NOR gate here. So now what I am going to do is I am going to make the connections of my firstly this AND gate. So this is my input 1 that I have just, the connections are same here, VCC to this 14th pin and ground to the 7th pin. Similarly, VCC to our this 19th, this 14th pin of 7427 and ground to our this 7th pin. Similarly, LED will be there and our resistance will be there. So we have to go for our this first, second and third input to our this AND gate. So these 2 gates, these are the 2 inputs that we are going to use of our this, that is pin number 13th and 12th. This is the output. Similarly, pin this, and this is the output. Similarly for our this gate. So let's start the connections. So we are giving the VCC, we are grounding the resistor, grounding 7427, grounding 7408. Then I have given the second input to my AND gate. So this is like we are giving A and B to our first gate. Then I am giving A and C to my second gate. Then I am giving B and C to my third gate, and the outputs now I am going to provide to my 7427. So here you can see that I have provided my, because 7427 has the pin configuration of this is my first input and these are my 2 inputs to my this first gate, first NOR gate, and this is my output. So these I'm going to connect. This is my first input and the rest 2 will be coming here. And then I'm going to take the output towards the LED. So now I am going to start my simulation because my circuit is complete. And now I am going to start my simulation. So you all should remember now that for more number of zeros, the output should be high because we are using a NOR gate here. So here you So here you can see that for 0, 1, 0, more number of zeros, output is high. For 1, 1, 0, output is low. For 1, 1, again it is low. For 2 zeros, again it is high. For 3 zeros, again it is high. So let's go for 110. Again it is 0. So let's go for 010 high, 011. Again it's low. So for more number of zeros, the output is coming out to be, here you can see, you can test any combination. Wherever you have got more number of zeros, the output is going to come out as high. So here it is more number of ones. So you can go for all the combinations. So let's start with 0, 0, 0, it's high. 0, 0, 1, again high. So now 0, 1, 0, again high. So now 0, 1, 1, it's low. So now 1, 0, 0, it's high. So now 1, 0, 1, it's low. 1, 1, 0, again low. So triple ones, again low. So this is how you can verify your this circuit using your 3 input NOR gate, because we had OR gate. So I have just inverted the output of the OR gate because of the limitation of my this IC that I am having. So that's all for today's problems. So hope you have understood this circuit well and you all will be performing it. Your comments are always welcome. Thanks for watching.